Okay, so the word problems are a little bit tricky. So for number 8, sum of 3 consecutive integers. So what I do, I make 3 slots, and I know it's sum, that's why I put plus in between, equals is 78, right? Now we don't know what the first number is, that's why we always call the first slot x. If the next number is 1 more, that's why we write x plus 1. And then if the next slot, right, is 2 more than the first, that's why you write x plus 2. So it's x plus 1, x plus 2 equals the total amount. Then you're solving for x. X essentially is the number in the first slot. So we're trying to figure out what that is first. So we combine like terms. X plus x plus x is 3x. 1 plus 2 is 3. Then we solve for x, right, by adding 3 and dividing by 3, and we get 25. So what that means is 25 is x, or the first number. And then the second number is x plus 1, or 25 plus 1, which is 26. And then the next one is x plus 2, or 25 plus 2, which is 27. So those are the 3 consecutive integers that add to 78. So for number 9, it's one of those typical problems. Someone has, a total amount that they spent. So general rule of thumb, that total amount is usually the largest amount. If you're not sure, put it on one side by itself and set it equal, if you're not sure. But it says the total amount they spent is $54, and that equals, it says that she spent some money on salad over 4 days, and then she spent money on a tip. So there's 2 things that total up to 54, the tip money and the salad money. Now we know the tip money, so that's why we didn't attach a variable to this 6. Although it says $150 for tip, if she leaves $1.50 every day for 4 days, $1.50 times 4 days becomes $6 that she leaves for a tip. That's a fact. We know that value. We don't need to attach a variable. Okay, so she left $6, but then how much did she spend on salad for those 2 to total $54? That's why we need a variable. She bought salads for 4 days. So 4 goes in front, and then S. 4 times the cost of a salad, right? So now we have our equation, and we solve for S. S is 12. So each salad costs $12. Okay, so number 10 is a little bit tricky. It says that someone catches a bus at 4 p.m. to ride 3.2 miles from his house to the dentist's office. He arrives at 4:30 for a 1-hour appointment. Then he rides a bus traveling at the same rate for 4.8 miles to the soccer field. Is he on time for his 6:30 p.m. soccer practice? So basically, I drew a picture, right? So he's at his house, and then he goes to the dentist, and then he heads to soccer. Now the question that they're asking, if he leaves at 4 p.m. and his goal is to get to soccer by 6:30 p.m., can he accomplish all of this in 2.5 hours? And we're not sure. We need to figure that out. So for these type of problems, I think it's easiest to kind of set it up thinking about it as, okay, the first part is the time, right, that it takes to get to the dentist, plus his wait time, right, plus the time to get to soccer. And we have to figure out, can he make it within 2.5 hours? So we have to add those up and see if he'll make it in time. Now figuring each of these out can be a little tricky. The one that's obvious is the wait time. They say he's waiting at the dentist's office for 1 hour. So we can just write 1 hour, or we know that's 60 minutes. Now we need to figure out the time to get to the dentist and time to get to soccer. Now, from his house to the dentist, even though he travels 3.2 miles, 3.2 is not a time. So we need to do a conversion to figure that out. So if we know it's 3.2 miles, right, we need to multiply by the rate. But we don't know the rate. So how we figure out what this rate is going to be, what we multiply by, we have to do a little calculation. If we know that distance equals rate times time, and we know that the distance traveled was 3.2 miles, we don't know the rate, but we know that the time that it took to get to the dentist's office, we know that time was 30 minutes, right? So 3.2 miles at a rate times 30 minutes. Distance equals rate times time. Because we know this is 30 because it said he left his house at 4 and he got there at 4:30. So we know it took 30 minutes. So to solve for the rate, we divide both sides by 30. So when we solve, we get that the rate is 0.10 miles per minute. Obviously, it's a lot less miles because it's per minute, not per hour. So that's the rate. So now that we know the rate, we can take the distance traveled and multiply by that rate. So we have 0.107 miles on the bottom. We have 1 minute on the top. And then the miles cancel. So we have on top 3.2 divided by 1.07, and that turns into about 29.9. So we'll say it's about 30, and this is in terms of minutes because that's the word, that the unit that's left. So the time to get to the dentist after all that work was 30 minutes. So this is the hardest problem on the whole thing. So the time to get to the dentist was 30 minutes. We waited for 1 hour or 60 minutes. Now we need to see the time that it took to get to soccer. So to figure out the time to get to soccer, we're going to figure this out, time to get to soccer. And it said that the miles to get to soccer, it was 4.8 miles. So we do 4.8 miles. Now that's not a time, it's a distance, right? So then we need to multiply by the rate, which we just found. The rate that we just found was that this person travels at 0.107 miles a minute. These cancel. And when we do this, 4.8 divided by 0.107, we get about 45 minutes. So the time to get to soccer is about 45 minutes. So if we make sure we're working with the same unit and we add up all the minutes, time to get to dentist 30 plus wait time of 60 plus 45, that gets us 135 minutes. And so when I look at that, I know that if the 135 minutes, 60 minutes is 1 hour, plus another 60 minutes is another hour, so that's 120, plus 15 more minutes gets us 138.5. So it took this person 2 hours and 15 minutes to travel. If they needed to get there within 2.5 hours, they did make it. Long problem, but that one's tricky.